Hello, my lovely students. I hope you are safe. I hope you are healthy. And I just want you all to know that I have been thinking about all of you during this crazy time that we're in. So just know that your teachers are thinking about you and we want to know that you're doing well and we're hoping everything's okay with you. Okay, so today we're going to look at parallel and perpendicular lines. You kind of brush on this in grade 9 when you look at what happens between a parallel set of lines versus perpendicular as far as their slopes are concerned. So by the end of the day, we want to be able to identify parallel, and I'm just going to write perp lines from our equations. And we want to be able to recognize something called negative reciprocal slopes. Okay, so if we're going to graph these, remember we're using our y-intercept and our slope, and we're going to graph both A and B. So I will graph A in red, and I will graph B in green. So with A, what's our slope? Remember, y equals mx plus b. The slope comes from right here. Whoopsies. Here's our slope. And our y-intercept happens right there. So we want to graph this point, and then we want to use our slope to move. So if we're looking at this one, our slope is 2, but we're going to force that to be a fraction. We're going to put it over 1. So it's up 2, right 1. And we're going to move from our y-intercept, which is going to happen at 0, positive 5. So that's for A. Then let's talk about B over here. If I look at my equation, my slope is 2 over 1, and that's an up to right 1. And then our y-intercept is the second part of the equation, this negative 1. So that happens at 0, negative 1. So let's graph these. Okay, A first. 0, positive 5. And then I'm going to use this slope to move to my next points. Up 2, 1, 2, right 1. Up 2, 1, 2, right 1. Okay, and then I'll draw a line to connect those. And then I'm also going to do this all together. So 0, negative 1 is down here, and then we're going to go up 2, right 1. Up 2, right 1. Okay. I feel like that's enough for me to be able to give you, okay, we want that there, there. There's that line. So if you were drawing these, you would have just lined up your ruler and always extend them farther than, like I just put 3 points, but I want to try and extend that as far as possible, just so I can really see the trend. Oh, I want full marks. Hold on. Hold the phone. Y equals 2x plus 5. There's my full marks on that one. So then let's do the same thing. Let's draw a green line through this one. So if I do that, and then I take this, and I drag it back like that. Oh, that looks pretty good. We're going with that one. A little bit of an arrowage there. Throw a little arrow down there. Lovely. Y equals 2x minus 1. So if we are looking at these two lines, based on the graphing that we did, these are parallel lines. These are parallel. Are parallel. And that's what this wants us to have a little statement. Compare the lines. How are the lines alike and how are they different? Well, the lines are parallel. Let's do that in blue because I always do my notes in blue. Okay, so lines are parallel. If we look at our information for the lines, what do we notice? This is y equals 2x, y equals 2x. The slopes are the same. So lines are parallel, slopes are the same, but then they have different y-intercepts. So y-intercepts are different. Let's check what we have here. Slope of the first one was 2 over 1. Slope of the second one was 2 over 1. Describe the relationship between these two lines. These two lines are parallel because their slopes are the same. Boom. Done. So if you've got two equations and you get them to say y equals mx plus b and you notice that the m is the same in both of them, you are going to have parallel lines, and parallel lines never cross each other.